When we're working with functions, we can add them, subtract them, multiply them, and divide them just like we can with numbers. The only thing you have to watch out for is the domain, especially when you're dividing functions, because you want to make sure that the denominator never equals 0. So let's do some examples of this, okay? So we've got two functions. F of x is the square root of x minus 1, and g of x is the square root of 4 minus x. And we're going to do the sum, difference, product, and quotient functions. And we're going to state the domain of these functions. Okay, so the sum is going to be f of x plus g of x, which means I'm just going to add those two functions. That's not too hard, is it? And the difference function is just going to be f of x minus g of x, which means we're going to subtract those two functions. And that's not too bad either, is it? Okay, how about the product? Well, that's going to be f of x times g of x, which means it's the square root of x minus 1 times the square root of 4 minus x. We can do a little more work with that. So we'll put it underneath 1 square root. And I have x minus 1 times 4 minus x. We'll do FOIL on that. And I'm going to get the square root of negative x squared minus 5x plus 4. And finally the quotient. Okay, so that's going to be f of x divided by g of x, which is going to be the square root of x minus 1 over the square root of 4 minus x. And if you want, you can put that underneath one big square root and put it like that. Okay, so what about figuring out what the domain is? Well, let's get the domain of f first, okay? So the domain of f of x is, it's the square root of x minus 1. So that means that x minus 1 must be greater than or equal to 0. So x is greater than or equal to 1. So it's 1 to infinity. And let's get the domain of g. Okay, so g of x is the square root of 4 minus x. That means that 4 minus x is greater than or equal to 1. And negative x is greater than or equal to negative 4. We're dividing by negative. X is less than or equal to positive 4. And so that's going to be negative infinity to 4. Okay, so what is the domain when we add and subtract and all that stuff? Well, it's going to be whatever numbers work for both functions at the same time. And it might help if we do a little number line right here. Okay, so I'll do f of x in red. So that's from 1 to infinity. And I'll do g of x in green. And that's from 4. That's going from negative infinity to 4. So where do they overlap? Well, they overlap between 1 and 4. So for all of these functions, we can only use the values of x that work for both of them, which happens to be between 1 and 4. So my domain is 1 to 4 for the sum. It's 1 to 4 for the product. For the difference, rather, and it's 1 to 4 for the product. Okay, what about the quotient? Well, notice that we have a denominator now that can't equal 0, so we have to make sure that x does not equal 4 because we don't want the denominator to be 0. So our domain is a little different for the quotient. It goes right up to but does not include 4. Okay, now composition of functions is when you put a function inside another function. And when you have a function of a function, it's called composition of functions. And so, for example, if I do f of g of x, that means take the function g and put it into the function f. And that might be written like this. It's got a little circle right there. Okay, you can also take the function f and put it inside the g function. And in that case, we would write it like this. G of f of x. Okay, so that's the notation. So here's an example. Given the functions f of x equals x squared plus 1 and g of x equals x minus 3, find f of g of x. Okay, so what we're saying is we're going to take the entire function g and we're going to put it into the function f everywhere we see x. So f of g of x is going to be x minus 3, and see the x is being squared, so I'm going to square the x minus 3 and then add 1. Okay, and let's go ahead and multiply that out. So it's going to be x squared minus 6x plus 9 plus 1, and our final answer, x squared minus 6x plus 10. Alright, determining the domain of a composite function can be a little tricky, because if I'm putting g inside f, all the limitations that I have on my g function carry over into my f function, and I have to also take into account the limitations on the domain of f. So here we go. Let's figure out the domain of f first. The domain for f is x cannot equal 2, because that would make the denominator 0, right? And so that we need to keep that in mind. Now, what's the domain for g? Well, the domain for g is x plus 3 must be greater than or equal to 0, which means x is greater than or equal to 3. So it is from 3 to infinity. Okay, now, if I do f of g of x, then that means that this square root thing is going in for this x right here. And remember that we cannot let this denominator be 0. So that means the square root of x plus 3 cannot be 2. Because if the square root of x plus 3 equaled 2, we'd get 0 in the denominator. So I'm going to square both sides. X plus 3 cannot be 4, and x cannot be 1. Okay, so now I have a new limitation. X cannot be 1, and x can go anywhere from 3 to infinity. So when I put those together, I get 3 to 1 and 1 to infinity. That's the domain of f of g of x. And finally, let's talk about how you can evaluate a composite function. So if I have these two functions, x squared minus 7 is our f function, and 5 minus x squared is our g function, what would f of g of 1 be? So I like to say we're going to work from the inside out. We're taking g of 1 and we're going to plug it into f. So let's get g of 1 first. G of 1 is 5 minus 1 squared, which is 4. And so f of g of 1 means we're going to do f of 4, because 4 is g of 1. F of 4 is 4 squared minus 7, which is 16 minus 7, which is 9. Okay, how about g of f of negative 4? We're going to work from the inside out, so let's get f of negative 4 first. That's going to be negative 4 squared minus 7, which is 16 minus 7, which is 9. So g of f of negative 4 is really g of 9. And that's going to be 5 minus 9 squared, which is 5 minus 81, which is negative 76. And that's how you evaluate composite functions.